Hello, I want to talk about transformations of quadratic, and actually this chart applies and cubics, which we will probably do at some point, as well as square root functions. So this is a chart that you might want to keep in a safe place as we work through. And the first function, because I couldn't get my printer to work, function, the graph will reflect over the x-axis. So basically it takes y equals x squared and an upside down U-shaped curve. The way I look at this, and certainly as I do some more videos, I say that the negative is outside of the function. In contrast, the inside of the function. When the negative is on the end of the function, what happens is we reflect the graph over the y-axis. So what's on the right side of the y-axis flips over to the left side of the y-axis and vice versa. You actually cannot see that reflection if you're looking at just the y equals x squared curve. You won't be able to see it by sight. It would have to be in an equation. Some of these formations, the next four in fact, if we have a function plus c, that means that we're going to move our graph up c units. And if we have minus c, that's going to move our graph down c. And those are both outside the function. In contrast, we have x plus c. The plus c is inside the function. And if you experiment around with that a little bit, what you'll find is that it actually moves our graph left c units. And here, still inside f of x minus c, we move right c units. If we multiply our graph by something outside of the function, which is the f of x, then this is going to be a vertical stretch. And it's actually, so far I haven't seen very much where they ask how much it's come into play for graphing. So if there's a fraction out in front, outside, this is going to be a vertical. And the real word is compression. But this program uses shrink. Again, that's outside the function. When the c is on the inside of the function, these are going to be horizontals. But like the inside ideas, when we moved left and right, this is going to be a horizontal shrink, as the program calls it. Again, a better word is compression. And then if we have a fraction inside of the function, then this is going to be a horizontal stretch. As I scoot this over just for a second, I don't know if you can see those last two are insides. Been very helpful on this unit. So feel free to use Desmos to help with some of those questions. It's easier than using calculator, and the nice thing on Desmos is that there's a table feature as well that might be able to help you And if you're unsure of how to use Desmos, or you would like help with Desmos, or need to ask any questions, please feel free to set up a virtual meeting with me in Cisco WebEx, and we will talk about these ideas.